Hello everyone, good afternoon. Well, firstly let me introduce myself. My name is Danial Fatchurrahman. I am master student in the first grade. Then here I'm going to present about my research in this education. And this is my first research entitled Fluorescence Imaging for Green Paper Grading System. Well, welcome to my presentation. Firstly here, this is my outline, what I'm going to tell you in my presentation. The first introduction, and the second is objective, material method, result, conclusion, and future plan. Well, we are going to introduction. What is material I used? This is about fluorescence technology. What is fluorescence? Here you can see this is light source, and this is object or fluorescence substances that can emitting light while once it is exposed by UV light, and this is eyes or camera. And you know, this is once the object is excited by light source, especially this is like a UV light, and it will emitting the same light, emitting some light or like this. And your eyes, this is your eyes, can catch this light. Usually it's called by emitting light from fluorescent. So this is fluorescence. And some previous researchers have observed, and they have been using this technology to identify about rice grain freshness and rotten cytosis, and also pistachio nuts contaminated with aflatoxin. And here I'm going to propose about green paper grading system. We know that the quality parameters such as color, forms that include damages, and shape become important factor to meet the price in the market. So here I'm going to focus on form or damages that usually caused by interaction between vegetables or between vegetable and hard things, for example stone. And this is like pictures I took before I'm doing my research. You can see some fluorescence phenomena in these papers or this green paper. You know that, for example, this I made an artificial SAR or image here, and it appears red color under UV light. And when I cut it, this is the cross-section area. There are so many different colors on it. So this is fluorescence phenomena. Well, here is my objectives. I'm sorry, this is 2 because usually it changes forms because I made it in Mac. Well, the first objective is this. I'm going to determine the proper system to get fluorescent phenomena from damaged green paper. And the second is to identify the physical causes for fluorescence signatures and identify fluorescence components in green paper in order to determine the proper excitation and emission for this component. Well, here is materials and method. You can see there are 4 pictures. This is like materials I'm using. I'm still doing my research, and this is these are materials I used. The first green paper, this is camera, and this is UVA lamps, and this is spectrophotometer. This spectrophotometer is the portable one. Well, this is the specifications of each devices. This is lamp, UVA lamp I used. That is black light blue lamp. It has peaks in 2 regions, in 2 wavelengths. This 352 and around 360 nanometers. And this is device about camera I used. This is CCD camera. and color camera. And this is portable spectrophotometer I used. And this is the spec that it can catch spectral range in 310 until 1100 nanometer. This is about design I have built for my experiments. That you can see, this is camera and this optical fiber. This is about the extensions device from portable spectrometer that can catch the light as a sensor. And this is computer as display that can display the pictures of samples. And this computer can give us information about the spectrophotometer. And this is about distance I use, and this is the lamp. And this is the real condition about my system. This is the sample, and this is the optical fiber I set here, and this is camera, this is two lamps, and this computer I used to get display picture from this camera, and this is to get the spectra information from portable photometer. I'm using this condition while I'm doing my research. I'm using black condition or maybe dark light condition. There is no light in this room. Well, this is about image I can get from the samples. You can see this is image taken from in front, and this is image taken by the system. This light, this fluorescent phenomena you can see from the samples. Then this is about the spectra. I got this is the reflectance spectra of sample. The blue one is reference. This reference is a condition where there is no sample in the system. And this red spectra belong to PMAN or green paper. This spectra is giving us information about fluorescent phenomena on the surface of PMAN or green paper. And it gives us peak in 678 and 712, where it gives us red color as the emission light. So this is conclusion, where with this system, I can identify fluorescent phenomena for green paper. And the second is the fluorescence excitation of green paper is in peak 678 and 712 nanometer. Well, about a plan that I'm going to do in the future is set and adjust the image acquisition system. And the second is identify fluorescent substances and proper excitation condition for these components by other device. Maybe the proper device is spectrophotometer that I can get this kind of information. Well, that's all my presentation. Thank you.
Question, my friend. Let's go to the system slide. No, this one. Why did you use spectrometer?
Spectrometer, yeah. The spectrometer is a device that I can use to get the reflectance light from the PMAN, from the paper. So from this, I can get information. I can make sure that the sample is absorbing the UV light and emitting in this region.
You use your UV light, or you use another light source?
I use UV black light.
What was the gap between the detector and the sample?
This 0.5 centimeter.
Okay, I will discuss with you about this.
Thank you.
Please go to the slide number 10. Camera is Shirisan. He use CCD and C mount. What is that? Usually camera is CCD or C mount camera.
Camera.
He use lens mount C and sensor type CCD. Okay. His information is correct.
I don't know what kind of camera did he use.
Usually lens mount C mount, but sensor type CCD. Little confusing. So I.
CCD was CCD.
This, you asked about the spec.
Okay.
I got from the company
Okay.
information.
Okay. Thank you.
Slide number 12. This is your picture because I know green paper color is the green, not yours. Not like orange.
Yes, I combined. I modify another pictures. You like the previous
You
research.
should modify this
Yeah.
picture.
I add some and I modify.
It's an orange.
Why do you use the UVA light? Why do you use a
Okay.
UVA light?
Well, last time I was trying two type of light. The first is
What are the basis to use the UVA light?
UV light. UV light is type of light that can be used.
I know.
Yeah, that can be used to make a fluorescence phenomenon. So, yes, this type of light is usually using by usually used to get the fluorescence phenomenon. Is that your question? What?
You use 350 nanometer light. 360 or 350 nanometer.
I use UV radiant light. This light can give us emitting the wavelength between 300 and 400 nanometer. So
Okay, can
it's
you
like-
explain the fluorescence, emission or excitation spectra?
Hmm?
What are the region? The most of the fluorescence substance, excitant spectra region.
Like this.
What the sensor?
You know this?
Mhm.
Usually, fluorescence phenomena can give us to information like this. This is excitation, and this is emission. Emission. So, like this.
But you got 600, above 600 nanometer.
Yeah.
678.
Almost NIR region.
No.
Visible region.
750 in the visible region.
Some people say also 700, up to 700 visible region. So, okay, you got the right reason.
Yeah. This is visible region. 700 to 750. It covers red. The visible region. And this is purple. 400 from this.
You know what is the substance peak in, emission peak in 672 nanometer?
672. Name of substances? I don't know because I don't do it yet.
It's a value.
I don't know about the substances type or the name of the substance inside of this paper, but that's what I'm going to do in the future.
Your goal is determining the substance of the fluorescence.
I'm going in the future.
How do you determine?
Well, this is about the nano device that I need to extract this type of For example, I get the peak. It is like now around 600, 672. Okay, until 612. So maybe the first time I need to make sure in literature what kind of substances in this region with the same peak. Maybe I don't know, but maybe, and then maybe I can get some reference, and then I try. This is some reference, and I try to cross check with my samples.
Don't you need to use any other analysis methods such as HPLC or?
Maybe, I don't know yet, maybe. Maybe it can be used HPLC or nuclear resonance to identify the compounds of the samples.
Okay. You have a comment? Question? Please show me slide 14. Yes, the picture. Where is Pima?
Prima. This is prima. This is prima.
Where is small?
No, this.
Is it difficult to make bigger picture?
This is the picture. I take a big picture. Maybe yes, I need to adjust this camera condition. But from this, you can see the fluorescent phenomena.
What is the right part?
This is fluorescent phenomena from the PMAP, from the image.
Maybe as something is taken with the Pima. Is that the right part one? So maybe
This is halation.
no, more right part. Maybe fluorescence light or something.
This part.
Yes.
This part is I use like plastic to hold the holder. Like I set. Yes, it has fluorescence. It has fluorescence. It has fluorescence, like a plastic. I use a plastic to hold. Yeah, to hold the optical fiber like this.
Fiber.
Yeah. I use plastic.
Okay, please try to take clear image. And not only UV image, but also the visible image. And I have last question. Is it possible to take fluorescence spectrum by using mixture, liquid, homogenized liquid?
I think it can use as long as it has fluorescent substances. It has
Maybe
fluorescent.
you don't need to measure the green paper directly. You can homogenize and extract. Then you can measure. That is more simple and you can get clear spectrum.
Yeah. Last time I tried it, but I got the solution is quite green, and also it's like so many contaminants inside. Like the color become dark. Maybe yes, oxidation is happening. Maybe it was happening in the time. Because once we cross the samples, or maybe we need to make a good extraction to get a good solution like that. But once I get the good solutions, if I expose it with UV light, I could not get the fluorescent phenomena because maybe, in my opinion, the fluorescence substances or concentrations was very low. maybe. Then it cannot emitting light.
Usually such substance is extracted by the filter and the liquid, ethanol, methanol, as a liquid. Then finally pure solution is measured.
Yeah. I'm thinking about that.
Okay, why don't you take the method?
Yeah. I'm thinking about that.
No other question or comment? Okay, thank you very much.
Thank you.